Welcome back to your free Windows 7 training. In this video, I will look at the IPv6 protocol that will one day replace the IPv4 protocol. There are lots of reasons to change to IPv6. IPv6 offers many improvements to IPv4. Things such as multicast have been improved. Multicast allows one computer to send a packet to many destinations. Encryption has been improved. IPsec is now integrated in the protocol rather than being a tacked-on add-on. The IPv4 network grew as demand grew, and thus the network is not laid out as well as it could be. With IPv6, more thought has gone into the geographical layout of the network than the IPv4 network, which grew as demand grew. The most noticeable difference between the two protocols is that the IPv6 protocol uses a much larger address space. There are many different ways that people have used to describe how many addresses are available in IPv6. The number of addresses is 2 to the power of 128, or 340 trillion addresses. To put this in perspective, IPv4 has over 4 billion addresses. Using IPv4, you could not even allocate a single IP address for every person on the planet. With IPv6, you could allocate 2 to the power of 95 IP addresses for every person on the planet. With this many IP addresses available, you cannot imagine that you would ever run out. The larger IP address space also allows you to have better and more efficient routing. IPv4 was not designed around efficient routing. It was expanded and allocated based on the need at the time. Because of this, Internet backbone routers have thousands of routes on them. IPv6 backbone routers, in comparison, have a smaller amount of routes. To understand IPv6 better, let's have a look at how IPv6 addresses are configured. IPv6 uses a 128-bit address, which is 8 blocks of 4 hexadecimal values. For example, the following addresses. IPv6 addresses are not the easiest addresses to look at and definitely hard to remember. To make the addresses easier to read, there are some rules that you can use to reduce the size of the address. First, you can remove any leading zeros down to a single number. Given this example, all the leading zeros can be removed from the groups of 4 digits. Removing the leading zeros makes the address a little easier to read. Notice that in this case I did not remove all the zeros, as there always needs to be at least 1 digit in each group of 4. If you have consecutive blocks of zeros, these can be reduced. Given the example, the first set of zeros can be reduced to a double colon, like this. Also given this example, the last set of zeros in the IPv6 addresses can be reduced. For example, it can be reduced to this. Both of these addresses are valid. However, reducing an address down to a double colon can only be done once per address. Thus, the following address is not valid. Once you understand how an IPv6 address is represented, the next thing to look at is the different types of IPv6 addresses. There are many different types of IPv6 addresses. If an address is determined to be a unicast address, this results in one-to-one communication. The network data travels directly from one host to the other. The host can be on the same network, or on the other side of the world, or somewhere in between. Unicast is used for most network communications, as most network communication takes place between a host and a server. For example, when you request a web page from a web server. The next type of address is multicast. This is when one packet is sent to multiple computers. For example, if you needed to install Windows 7 on a number of computers at the same time, if you used unicast and were installing Windows 7 on 100 computers at once, every packet would need to be duplicated on the network 100 times. Multicast can send one packet to 100 computers at once. Assuming your network and software can support it, multicast can save you a lot of bandwidth. You can tell a multicast address because they start with FF. The last type of address is anycast. Anycast is when one packet is sent to one of many destinations. For example, if you had the same service installed on many servers throughout your network, you would want the client to be directed to the nearest one. Using anycast, you can use the same destination IP address on each host, and your routers will direct the client to the nearest server. To use anycast, your network needs to be configured to support it. Looking closer at unicast addresses, these can be divided down into 3 types of addresses. First, there is the global unicast address. This is like the public IP address used in IPv4. Global unicast are centrally managed and routable on the Internet. You can tell a global unicast because the IP address starts with 2000 or 2001. When you receive a registered global IPv6 unicast address, you can be assured that your IP address is unique and that anyone on the Internet will be able to contact you using it. Next, you have the address link local. This is similar to APIPA addresses used in IPv4. The big difference is that a link local address is always present on your network card. This is because they are used for essential services such as neighbor discovery. In IPv4, if your computer attempts to communicate with another computer on the same network, the computer does not know the MAC address of the other computer. The MAC address is a unique address assigned to every network card and is guaranteed to be unique. It is used so network adapters can communicate directly with each other. To find out this MAC address, the IPv4 computer would then send out a broadcast message that all computers on that subnet would receive. This is a waste of bandwidth, since only one computer on a network with possibly hundreds of computers would respond to the broadcast, but all computers on the network would receive it. Neighbor discovery helps to eliminate the need for broadcasts. It performs functions like finding other hosts' MAC addresses, finding routers, and used for auto-configuration. All this is done without the use of broadcasts. Since it is used in so many functions critical to network communication, this is why every network adapter has one of these addresses even if you manually configure an IP address or an IP address is obtained from a DHCP server. Link local addresses always start with FE80. If I were to run ipconfig from the command line, you can see the link local address that has been assigned to the adapter, even though this adapter has an IPv4 address assigned to it and no IPv6 address. If I were to configure an IPv6 address on this link local address would still be present. Link local addresses are IP addresses that will be configured automatically and can communicate only on your local network. They are not routable. The next address is unique local address. Sometimes you will see this referred to as site local, but this is an old term. These addresses are like IPv4 private addresses. You can allocate these IP addresses any way you want, but these addresses are not routable on the Internet. You can, however, route these addresses any way you want inside your network. Unique local addresses start with FCOO or FDOO. You can also start with FECO, but this is the old standard which is being deprecated. There is one more IP address you may come across, and this is the loopback address. In IPv6, this is represented by ::1. If you attempt to connect to this address or send data to this address, it will be redirected back to the local network card. The loopback address is primarily used to check if your network card and its software are running. This will not test if you can send data on the network because the loopback address will still work even if the network cable is not plugged in. Each day, more and more devices support IPv6. In the real world, IPv6 deployment has been slow. It is surprising that few ISPs even support IPv6, meaning that going out and buying an IPv6 device may be a waste of time. If you want to start using the IPv6 network and don't want to wait, consider downloading the GoGo client from GoGo6, available from their website. This client allows you to connect up to the IP6 network without having to upgrade your equipment. This concludes IPv6. In the next video, I will look at how to troubleshoot the IP protocol. For more free videos, exam questions, and study guides, make sure you check out our website.